A black hole is coming straight for Earth. We could wait for it to gobble us up, but instead we're going to try to destroy it. We'll throw everything we can at this black hole, from nukes to advanced technology that we might not even have access to yet. Maybe we'll even try to throw a white hole at it. Is it even possible to destroy a black hole? You know what, enough questions. We have a serious mission to accomplish, and if we don't, humanity will go extinct. This is what if. And here's what would happen if we destroyed a black hole. Okay, our first attempt at destroying this black hole will be to nuke it. We're going to collect every single nuke on Earth and launch them at this black hole that's speeding right toward us. This will produce energy equivalent to 425,000 times the atomic bombs of World War II. Now we know that the destructive blast of a nuke decimates anything, so all these nukes should do the trick, right? Well, not so fast. Black holes are tricky because what they do is consume like some kind of super hungry space giant. They want to suck up all the matter and energy that they can get their grubby little cosmic hands on. But let's try launching our nukes anyway. As they enter the black hole, you sit and wait for the massive EXP explosion that will destroy this celestial phenomenon. But instead of being destroyed, the black hole eats the nukes for a snack. And now it's more massive than before. Great. Well, as the saying goes, that which doesn't kill a black hole only makes it stronger, or something like that. Bullets, lasers, and ginormous super weapons won't work either. So, is humanity just expected to suffer the fate of being gobbled up by the black hole? No, you are not going to let the human race die out, but it's clear we have to try a more crafty strategy, one with artificial black holes, white holes, and maybe even a time machine. But before we get to that, let's figure out the basics after all. As Sun Tzu said, know thy enemy. So what makes a black hole tick? Black holes are these super dense areas in space, so dense and so gravitationally strong that not even light can escape them, and it's estimated that our Milky Way galaxy has 100 million of them. Now, a black hole can form in two different ways. One way is when a cloud of gas collapses. These types of black holes can be enormous, 1,000 to 100,000 times the mass of the sun. And there's a second way stellar mass black holes form when a massive star explodes and dies, leaving behind a very dense core, which is the black hole. These are smaller with masses just a few times that of our sun. Now, what happens when we get a little bit closer? Well, as you approach the mouth of the black hole, you reach a boundary called the event horizon. And once you cross the event horizon, well, you're past the point of no return. Its pull is just too strong. Like I said, even light can't escape. And if you fell in feet first, you'd actually be stretched and squeezed simultaneously by the extreme gravity and pressure. The official term of what would happen to you is called spaghettification. Sadly, it's got nothing to do with meatballs or a nice bolognese sauce. The scary thing, of course, is that black holes are constantly growing bigger and bigger and bigger by swallowing more and more matter, and now it looks like Earth and all of humanity is on the menu. Oh, and one last thing about black holes. Like many other objects in our universe, they have angular momentum. In other words, they spin and they have a charge associated with them. These are properties that need to syn up appropriately with the mass of the black hole in order to keep it in business. Just like, if you were running a marathon, your body temperature and your blood pressure must stay in the right zone so that you can keep running. If you overheat, you might faint and fall over. Keep this in mind, as it might play an essential role in taking down our black hole. Right now that you've got a handle on what we're dealing with, well, it's time for a new attack. Oh yeah, we know we can't defeat this sucker by simple tricks like nukes. No, we've got to come up with something better. So, well, we're going to do something pretty crazy. Let's try making our own black hole and see if it can defeat the one coming after us. But how do we do this well? The first step is making our black hole out of antimatter. Antimatter is just like matter, but with all the opposite properties. It's like the arch nemesis of a black hole. Of course, there's the small problem of actually making a whole lot of antimatter, but no worries. We have the technology to pull this off. All you have to do is accelerate a bunch of protons until they're nearly at the speed of light, and then you fire them into a material like iridium. This collision knocks out some of the fast-moving antiprotons, and the antiprotons are then slowed down and focused to help create antimatter. Oh, and we'd probably need this anti-proton gizmo floating in space to create an antimatter black hole at the right coordinates. Definitely a little tricky to pull up off. So what's going to happen when we crash our antimatter black hole into the regular black hole? Well, once these two forces crash, there'd be a mega explosion of pure energy, but unfortunately, it doesn't work as intended. The energy from our antimatter just gets vacuumed up by the regular black hole, and it's now even bigger. Okay, this is not looking good, and the black hole is getting closer and closer and bigger, and we're running out of time. We've got to try something else. Since the black hole is getting bigger from us feeding it, well, maybe we could just starve it. What if we figured out a way to stop it from eating anything else? Well, that wouldn't work either, because the original mass of the black hole would still exist. But what if he tried the opposite? What if instead of starving the black hole, you fed it with something that's constantly throwing stuff out? But what could that be? My mom, maybe the answer is a white hole. White holes function in ways opposite to black holes. The two of them are like yin and yang. If nothing can get out of a black hole, well, nothing can get into a white hole. If we threw a white hole at a black hole, the two might just annihilate each other, but they wouldn't disappear. There'd be a big burst of energy and a ton of gamma radiation. You'd want to steer clear of that zone. That radiation will give you cancer. Well, actually, you'd get such a massive dose that you'd probably just die instantly. Besides this, the only problem, well, we don't actually have a white hole and we don't know how to make one either. Okay, so that strategy is a bust, but we're not going to let that stop us. We will stop the black hole. This sounds a little crazy, but what if we built a tin machine, one that could go back in time and take a black hole out? All we need is a wormhole to connect the black hole with its past. As we go back in time, the black hole has to spit out the mass it's taken in, making it a white hole, and if we traveled back far enough, we could reach the point just before the hole was born, and blast it with nukes or lasers or whatever we have on hand. This idea works in theory, but we don't have a time machine or a wormhole. Let's try something a bit more realistic. Alright, I got another idea. Maybe we can make a bomb that explodes spectacularly fast. I mean faster than the speed of light. We need the speed, because remember, even light can't escape a black hole, so we'd need an explosion with escape velocity faster than the speed of light to blast out of there. If we did this, it might blow the black hole apart. The only hitch is we don't have a bomb that explodes that fast yet. So what else could we do? Okay, well, maybe you could deform this black hole. Target a specific part of it. Something like that might kill it. Well, guess what? We've got 4 different deformation options. How about attacking what lies at the heart of a black hole, that is its density? If we stretched it out and took away its density, well, that would spell the end, but it can only be stretched if it has a finite size, and science isn't sure if black holes do or don't. The problem is, we're not 100% sure about the exact nature of what's inside the black hole. Is it a super dense, stretchable object or region, where space-time curves, which would not be stretchable? Well, we don't know for sure, because nobody's made it past the event horizon. Remember the spaghettification thing, but even without that knowledge, there's a second way you can destroy a black hole, and that's by destroying the event horizon. Without the event horizon, well, frankly, there's nothing for objects to fall into. One way to destroy the event horizon would be to poke a hole in it. If we just puncture the boundary at the event horizon, maybe the mass of the black hole would start to drain out, and with no mass, the black hole would no longer exist. But there's a third, more sophisticated way to deform the black hole, and it's got to do with some of the forces keeping the black hole going. Remember, I told you that in order for the black hole to exist, the rate at which it spins and the electrical charge of the black hole have to stay within certain parameters. Remember that, yeah, like when you turn your car around a corner, it needs a certain acceleration to make it around the corner safely. Overdo it, and you might get into some trouble. Well, we want to destroy the black hole. So we're going to mess with these parameters. What if we increase the spin and amped up the charge of the black hole so much that its equilibrium broke down? This could be the final answer to destroying our black hole, or we end up destroying the universe. So let's try something else. Now, could we just slow the spin of the black hole? Sure, we can extract energy from the black hole by dropping things into the event horizon. This will make the black hole rotate more slowly if we did it enough. We could even make it stop spinning entirely. Now, this might slow it down, but it won't make it completely disappear. Okay, so there is one last option, and it's all about patience. See, black holes can destroy themselves over very, very long periods of time, and it's because of a weird process that's going on in the background. According to quantum theory, everywhere around us, pairs of particles are popping up, a particle and an antiparticle. When these crash together, they destroy each other. But in the case of our black hole, one particle might go into the hole, and the other particle might escape into space. As this happens, over time, the black hole becomes a teeny tiny bit smaller, and if we wait a few trillion years, the entire black hole will dissipate this way. You know, they say ignoring your problems doesn't usually solve them, but in this case, it will, after a few trillion years. So, can we destroy a black hole? No, not really, and even if we could, I'm fresh out of new ideas, so if you have any theories of your own, head on over to our Patreon where you can join a private Discord to chat with us. Maybe you can help us solve the problem. But let's be real, a force this strong is virtually impossible to get rid of. Luckily, the chances of a black hole coming for Earth are just as impossible, but if it did happen, maybe our best chance would be to get away from it as fast as possible. But that sounds like a story for another what if.